So this video is going to be on simplifying derivatives. This is one of the most difficult aspects of calculus for a lot of students. And the reason is because it has nothing whatsoever to do with calculus. It is straight algebra. It's just about rearranging everything, combining like terms, factoring out common factors, and getting down to your final simplified answer. So we're going to look at 3 examples. And these are going to be simplifying raw derivatives of functions involving products, quotients, and compositions. Okay, so we're going to start with a complicated multiplication problem here. This is a product, but inside of the product is also a chain rule, right? This is a general power rule. First thing you want to do is to start by rewriting the square root as 1 minus x squared to the 1/2 power. The reason we do that is so now we can use the general power rule. So, not equals, f prime equals, this is a product, so first times the derivative of the second. I'm going to put it in parentheses so I don't lose anything. So 1/2 comes out front, rewrite the 1 minus x squared, and then decrease the exponent by 1. Then we're going to multiply by the derivative of what's in the parentheses, so negative 2x, and close our parentheses, plus the derivative of the second, or the derivative of the first, times the second. So we're going to multiply all of this together because this is one term being added to another term, so we need to go ahead and combine everything. So the 1/2 and the 2 cancel out. I've got negative x times x squared, so negative x cubed times 1 minus x squared to the negative 1/2 power, plus 2x to the 1 minus x squared to the 1/2. Now I could go ahead and move this to the bottom because it's a negative exponent, right? Because that's one of the things that we can't have is having a negative exponent. But I'm going to show you a trick. Remember, when we factor a common factor out, if we're talking about exponents, like if I had x to the 5th minus x cubed plus x, and I wanted to factor out my common factor, which is obviously x, which one do I factor out? I factor the least out, right? So I can pull 1 out. So if I pull 1 out, I say 5 minus 1 is 4, 3 minus 1 is 2, and 1 minus 1 is 0, so it just leaves x to the 0, which is 1. So notice I always subtract whatever I pulled out. Let me give you a pretty example here. What if I had x squared plus x to the negative 1? Do I have a common factor? Sure, x is common in both of them, right? Which one is the least? Negative 1 is. So I can factor a negative 1 out. So what's 2 minus negative 1? Yeah, that's 3, right? And then x to the negative 1 divided by x to the negative 1, we get the plus 1. So notice, if you factor out a negative, you're going to add it to any positive exponents. All right? So that being said, let's do this. Do I have a common factor? Absolutely. The 1 minus x squared is a common factor, and I have x's that are in common. So that tells me that I can factor out an x and a 1 minus x squared. But how many x? I can only pull out one x, right? Because that's the least. How many 1 minus x squareds? I've got negative 1/2 and I've got positive 1/2. I can pull the negative 1/2 out. And if I do that, what's going to be left here? I've got a negative and I've got an x squared. But I factored this out, right? A negative minus a negative is positive, so they cancel each other out. I don't have anymore. So plus 2 times, because the x comes out, what's 1/2 minus negative 1/2? Well, that's just 1. So I don't have an exponent anymore. So I can say this is x over 1 minus x squared to the 1/2, right? And then on this one times negative x squared plus 2 minus 2x squared So this is going to give me, I can go ahead and write it as x times negative 3x squared, right? Negative x squared and negative 2x squared is negative 3x squared plus 2 all over 1 minus x squared to the 1/2. And there's your final answer. Looked like Pac-Man there for a second. A lot of algebra. Is the calculus hard? Well, I'm not going to lie to you. It's not easy, but the hardest part is legitimately the algebra of this. So let's look at another one. Here we've got a quotient, but notice that we've got this general power rule inside of our quotient. So we're going to rewrite this as x over x squared plus 4 to the 1/3. I'm going to show you another trick. This is a quotient. We know we can do low D high minus high D low over low low. But I can also rewrite it as this, right? Bringing the 1/3 up and making it negative. Nothing wrong with that. However, for simplification, a lot of times it's easier to leave it in this form than it is this form because, well, things are going to cancel and things like that. So I'm going to actually do it both ways, and you can figure out for yourself which one you like better. So let's do quotient on this side. So this is going to be the quotient. And then we'll do the product over here. All right, so quotient, low D high, so the derivative of x is just 1, minus high times D low. So bring the 1/3 out front, times x squared plus 4, subtract 1, so negative 2/3, times the derivative of what's in the parentheses, 2x. Close the parentheses, all over low low, or x squared plus 4 to the 2/3, right? If we square that, that would be 1/3 times 2, which is 2/3. So on the top, we have x squared plus 4 to the 1/3 minus, we're going to multiply 2 times 1/3 gives us 2/3 x squared. As everybody see, we've got an x, we've got an x, we've got a 2 and a 1/3 times x squared plus 4 to the negative 2/3. All this over x squared plus 4 to the 2/3. All right, so do we have a common factor? Absolutely, x squared plus 4. How many can I factor out? Well, negative 2/3 is the least, so let's factor out the least. So 1/3 minus negative 2/3 is 1. So we're left with x squared plus 4 minus 2/3 x squared, and the x squared plus 4 canceled out, all over x squared plus 4 to the 2/3. So since this is a negative 2/3, we can bring it down to the bottom, and 2/3 plus 2/3 is going to give me 4/3. So we have x squared plus 4 to the 4/3. And on the top, we've got x squared minus 2/3 x squared, which leaves us with 1/3 x squared plus 4. So we have 1/3 x squared plus 4. So that's quotient. Low D high minus high D low over low low. Let's look at product. So product we do first times the derivative of the second. So negative 1/3 times x squared plus 4, decrease by 1, so minus 4/3. And then derivative of x squared is 2x plus second times the derivative of the first, so x squared plus 4 to the negative 1/3 times the derivative of x, which is just 1. I didn't close my parentheses up there. All right, so what do we have here? negative 2/3 x squared, so negative 2/3 x squared times x squared plus 4 to the negative 4/3 plus x squared plus 4 to the negative 1/3. All right, so which one is the least? Negative 1/3 or negative 4/3? Negative 4/3. So we're going to factor out negative 4/3. It's going to leave us with negative 2/3 x squared, right? Plus, here, what's negative 1/3 minus negative 4/3? So negative 1/3 plus 4/3 just gives you 1. So you have plus x squared plus 4. So we can combine negative 2/3 x squared plus 1x squared is going to give us 1/3 x squared plus 4. And that negative 4/3 can go to the bottom, x squared plus 4 to the 4/3. Two different ways, same answer. I like the product rule. I find that there tends to be less ambiguity. You're still having to do the same type of factoring, the same type of thing, but I like the product rule. Totally up to you how you do it, though. I will never say you have to use the quotient rule or you have to use the product rule. Our last example here. Here we have a quotient inside of another function. So we've actually got the chain rule on the outside here, right? So we're going to do this as y prime equals, bring the 2 out front, leave the function alone, decrease by 1, then take the derivative of the inside function. So now we're going to do low d high, so low times d high, which is just 3, right? Derivative of 3x is 3, derivative of negative 1 is 0, minus high, 3x minus 1, d low, derivative of x squared is 2x, derivative of 3 is 0, so we don't worry about it, over low low, x squared plus 3 squared. So we're going to have 2 times 3x minus 1 over x squared plus 3. Up here we're going to have 3x squared plus 9 minus 6x squared plus 2x all over x squared plus 3 squared. Does everybody see where that came from? We distributed the 3 to get the 3x squared plus 9. We distributed the 2x with the minus sign. So 2x times 3x is 6x, making a minus sign squared. 2x times negative 1 is negative 2x, but the minus sign makes it plus 2x. So notice we're going to wind up with 2 times 3x minus 1 over x squared plus 3. We've got 3x squared minus 6x squared, which is negative 3x squared plus 2x plus 9 all over x squared plus 3 squared. So when we multiply this out, I'm going to leave everything in factored form. So 2 times 3x minus 1 times negative 3x squared plus 2x plus 9 all over x squared plus 3. We have 1 here, 2 here, so cubed. And that's your final answer. So if you have any questions about simplifying derivatives and when you need to do whatever you need to do, please shoot me a reminder or make sure to ask a question in class.